Thank you for joining. This is a networking lab demonstration. In this lab, I will demonstrate port address translation, or PAT. The configuration is also referred to as NAT overload. Here's my network's topology. The end goal is to access the default web page of an external web server. I'll need to travel over the internet to access it. There are two routers, router 1 and router 2. Each of the routers have one interface with a private IP address and one interface with a public IP address. Network 3.3.3.0 is being used to simulate the internet. Its current configuration allows for router 1 to communicate over the internet and connect to the web server of an external network. For the purpose of this demonstration, Network 10.0.0.0 represents a private IP network, while all other networks represent public IP addresses. Using an ACL, the external network blocks our local network addresses but permits translated addresses. You may be asking, how will PCs on the local network gain access to the internet? Well, router 1's serial connection will supply the local network with a public IP address via port address translation. Let's take a look at router 1's configuration. The local address on interface G00 is 10.0.0.1. For the serial connection, the IP address is 3.3.3.1. This is the connection to the internet. This is the default gateway address configured on the end devices of the local network. I'll confirm the IP address of PC6. All of the PCs will be tested and retested for connectivity, but I'll use this PC later to view the default page presented by the web server. Okay, I confirm that the IP address is a blocked address. It is 10.0.0.6, which is of course within the range of the blocked private network range. I also confirmed that 10.0.0.1 is correctly configured as the default gateway address on this device. Okay, now I'll go into the web server of the external network to confirm the IP address of the server. Right away I can see proper configuration of the default gateway as 1.1.1.1. I can also confirm that the IP address of the web server is 1.1.2. Before PAT is configured, I'll test connectivity to the external network by pinging the web server of the external network 1.1.1.0. I'll start by having router 1 ping the web server. The server's address is 1.1.1.2. The ping is successful. Remember, router 1's serial interface has a public IP address which is acceptable for communicating over the cloud. Now let's test the PCs. I'll test PC6. All PCs have been configured with a default gateway of 10.0.0.1. Sorry, hang on while I adjust my topology for clear viewing. Okay, PC6 pings 1.1.1.2. The communication is blocked by the access control list of the external network. Remember, this control list is being used to block private addresses and allow public addresses. In this simulation, network 10.0.0.0 is identified as a private network and all other networks are public. There is routing between R1 and R2, so that's not a problem. I probably should have shown you that. I'll take a step back. I'm pulling up the router's CLI. I'll show you the dynamic routing configuration by running the command show IP route. As you can see, RIP has been set up for both of the router's interfaces. R is indicated for the RIP routing algorithm. Okay, I'll finish testing the remaining PCs to show the absence of connectivity. I've already tested PC6, I'll pick back up with PC7. The ping fails as expected. Next is PC8. It fails. Almost done. Next I'll test PC9. Like the others, it fails. And finally, PC10. It's official. All PCs lack connectivity to the external network. To communicate over the internet, they must communicate via a public IP address, but they currently only have access to their own private IP addresses. I'll have to change that. 2 commands must be issued on router 1. They are listed on the screen. The first command creates a list of network addresses. I want all of the PCs to have internet access. This command creates an ACL or access control list to hold this group of addresses. The second command applies the list to an interface for PAT or port access translation. The command points to the interface of the router that holds the public address. First, I'll open the CLI of router 1 and confirm that no ACL currently exists. Okay, confirmed there are no existing ACLs. I'll issue both commands now. The access list has now been created. Finally, NAT overload or PAT has been configured on the local network. I'll run a show on the ACL again. And here it is listed. I'll retest the PCs beginning with PC6. The ping is successful because PC6 is using the router's IP address under the newly configured port address translation. I'll ping again to achieve a full ICMP success rate. Okay, all 4 packets sent have been received, no losses. I'll retest PC7. Post-pack configuration. The ping is now successful. I'll move on to PC8. Confirmed. It can communicate with the external web server. Now for PC9. It successfully connects to the web server. Now for the last PC, PC10. Perfect. PC10 connects to the web server. I'll pull up the web server using the browser of PC6, but first let me do something. I'll change the local network label to indicate that an access list for the local network has been created and that ACL is used for port address translation of network devices. Give me a moment. I'll just add some clarification that the ACL is not being used to block traffic, but instead to translate the addresses of incoming traffic from the G00 interface. Okay, that should do it. I'll pull up the web browser on PC6. I'll go into the desktop of PC6 and select the web browser. I'll enter the IP address of the web server that we have been pinging. That would be IP address 1.1.1.2. I've already gone into the web server and updated the HTML of the default web page. A personalized welcome message appears. And that's it. Thank you for watching. For more Networking Lab videos, browse the playlist. Goodbye for now.